Okay, we're going to work a couple of problems off of the homework 5.1.1, which looks like this, and can be found in this formula or on Canvas, whichever one you prefer to print off of, but I would recommend printing this one. I'm going to work on a separate sheet of paper just because, again, I write big, and getting these little graphs to fit in there is kind of hard for me. So I'm going to start with number 5. Hopefully you found the sheet of paper that's also in this folder about all of the tricks to graphing rational functions, so that's going to be really helpful. If you haven't done that yet, go ahead and pause the video and take a minute to go and either print or copy by hand that piece of paper. That'll be really helpful for you. Okay, so on number 5, it doesn't ask me about the domain, but I do like to find the domain first so that it helps me find my vertical asymptotes and my holes that are in my graph. So I'm going to start with my domain. So my domain is going to be where anything that makes my denominator be equal to 0. So in this case, I know that x is equal to -2 is going to be a place that affects my domain. So I can't plug -2 into my function and still have a function, because it would make my denominator be equal to 0. So remember, with rational functions, it's not okay to have a denominator that's equal to 0. All right, the next thing on your hints sheet is about some holes, and this one does not have a hole. It's only going to have a hole if you have a factor on the top that will cancel out completely with a factor on the bottom. So by factor, I mean like x plus 2. So if I had x plus 2 on the top and on the bottom, then I would have a hole in my graph, and I'll show you an example of that here in just a little while. All right, so my vertical asymptote is going to be anything that's left in my domain after I do my hole, which, since there wasn't a hole, it's just going to be my domain. So my domain, my vertical asymptote, is going to be x equals -2. And I'll show you what a picture of that looks like here in just a minute. Okay, also in our little cheat sheet, I talk about how to find horizontal and slant asymptotes, and we'll just consider all of those horizontal asymptotes. So a horizontal asymptote happens if I have a degree of the top, which the degree of this one is 1, and the degree of this one is 1. So if the top is equal to the bottom, it is going to be a horizontal asymptote. So by degree, we mean the biggest exponent on x. And so it's a 1 on the top and a 1 on the bottom. They are equal. So to find that, I'm going to do y equals, and I'm going to take my lead coefficient of the top and divide by my lead coefficient of the bottom. So I'm going to have a horizontal asymptote at y equals 3. And it's what OnRamps also calls end behavior. We'll talk a little bit about that when we graph here in just a second. All right, the other two things we need to find are our intercepts. And so to find our x-intercept, I'm going to take the top and set it equal to 0. So that tells me that x is going to be equal to add over my 5 and divide by my 3. So I'm going to have an x-intercept at 5/3 0. Or for graphing purposes, we could change that into 2 2/3 and 0, so a little bit above 2 or a little bit below 3. And then I have a y-intercept anywhere that I'm going to put in 0 for x. So I'm going to go up there to my function and put in 0 for x. And so that's going to go away, and that goes away, so I end up with -5/2. So my y-intercept is going to be 0, -5/2. All right, so I'm going to use all of this to help me draw a little picture of my graph down here. And again, like I said, I write big, so my graphs are kind of big. Okay, so let me start with my vertical asymptote at x equals -2, so that's going to cross the x-axis at -2. And my horizontal asymptote at y equals 3. Going to be kind of right here. Okay, and then I'm going to have an x-intercept, so where it's going to cross the x-axis at 2 2/3, so kind of right there-ish. And a y-intercept of -5/2, so -2.5 would be kind of right there. So that gives me 2 points to connect and go out towards my asymptote. And same thing here. So this is why they call that horizontal asymptote, talking about our end behavior, because it tells me that it's going to kind of level off right there as this graph goes off into infinity. It's not going to cross over that horizontal asymptote. Okay. On the other side, I know that my graph has to be up here because I've already graphed my x-intercept, so I can't cross the x-axis again over here. I know it's going to be up here, but I would like to have one point to kind of attach it to. So I'm going to go and find out what happens when x is equal to -3. Okay, so I'm going to find a point at -3 something, and to do that, I'm going to plug it back into my original function. So 3 times -3 minus 5 over -3 plus 2. So I took -3 and plugged it in for x back up here in my original function, all the way back up there at the top. So that's going to give me -9 minus 5, which gives me -14 over -1, so that's just going to give me 14. So I've got another point at 314, which is going to be kind of way up here, but at least it gives me something to attach my graph to. And so my graph's going to look a little bit like that, going towards my asymptotes without actually touching or crossing them. Okay, let's take a look at number 7. So on number 7, a few things change because of the squared. Let me get mine copied down real quick. So 4 over x minus 2 squared. Okay. In my hints, it says to factor first. This one, again, just like the last one, won't factor. So I'm going to start with my domain, and I'm going to say that my denominator cannot be equal to 0. So if I take the square root of 0, I'm still at 0, so that's going to give me where x is 2. So my domain here is going to be from -infinity to 2, and from 2 up to infinity. So we'll stop at 2 and hit that asymptote, and otherwise use all of my x values. Okay, I only have a hole if a factor cancels out. Nothing's going to cancel on this one, so no hole. So my vertical asymptote is just going to be what I have right there in my domain, so x equals 2. Okay, my horizontal asymptote, I'm going to look at the degree of the top. There's no x's on the top, so that's going to be a 0. And the degree of the bottom is going to be a 2, because that's going to be an x squared if I square all of that out. So the degree of the top is less than the degree of the bottom, which gives me a horizontal asymptote automatically at y equals 0. You don't have to do any more math on that. If top is less than bottom, then your horizontal asymptote is y equals 0. All right, this is kind of interesting. My x-intercept, when I take the top and set it equal to 0, 4 doesn't equal 0, so there is no x-intercept. I also know that because my horizontal asymptote is going to be right there on the x-axis. So it can't cross the x-axis with the horizontal asymptote being there with only one vertical. And we'll talk about, there's kind of some special situations, but for right now, with one vertical asymptote, we're not going to cross. All right, and then my y-intercept, I'm going to plug in 0 for x, so that'll be 4 over 0 minus 2 squared. Watch for order of operations here. So that's going to be 0 minus 2 gives me -2 squared gives me 4. So my y-intercept is going to be at 0, 1. Alright, let me draw some graph paper here. So I've got a vertical asymptote at 2, x equals 2. So right here. Okay, and a horizontal asymptote at y equals 0. That's just going to be right there on my x-axis. Alright, and then I'm going to graph my y-intercept at 0, 1. So that'll be kind of right there. Okay, so I know this side over here does this. Alright, and then this one's kind of weird because of the squared. I know that this side's going to be up here as well, because if I look at this, my positive over what's going to have to be positive because it's squared is going to give me a positive. But again, we can plug in a value and check on that. So let's plug in 3. And so that'll give me 4 over 3 minus 2 squared, which gives me 4 over 1 squared, which is 1. So that gives me 4. So I've got another point at 3, 4. So 1, 2, 3, 4. Puts me right here. Okay, so So the other side of my graph will look like that. Okay, so kind of mirror images of each other over that vertical asymptote. All right, let's take a look at number 9 now. Number 9. This is where we get into one where we're going to want to start with some factoring. It's not going to be a huge help to us, although it'll help us when we get to our asymptotes. But nothing's going to cancel out, so I don't have a hole on this one. All right, so let's start factoring. That's going to be 3x and x. And then my factors of 5 are going to be 5 and 1. And I want to have negative 15 plus 1 to give me negative 14. And then over here, 3x and x again. And let's see here, 16 will go into 4 and 4. So that'll give me 12. And 4, which when I subtract will give me 8. I'm going to have positive 12 minus 4. So again, it'd be nice if some of that canceled out and we didn't have to work with the whole thing. But that's all right, we can work with it. All right, so on this one, when I go to look at my domain, I'm going to say that both pieces cannot be equal to 0. So this one, x cannot be equal to 4/3. And x cannot be equal to negative 4. So when I write that, I'm going to do the negative 4 first. I'm going to go from negative 4 to 4/3, because again, it's going to bump right up against those asymptotes. Whew, I'm running out of room. And then keep going. So it'll go right up to those asymptotes, and then it's going to keep going. Okay, again, no factors are going to cancel out on this one, so there's no holes. The last example we do, number 11, will have a hole, so you can see that in just a minute. But no holes on this one. All right, so my vertical asymptotes, I'm going to have 2 of them. I'm going to have one where x is equal to negative 4, and I'm going to have one where x is equal to 4/3. And kind of a funny thing happens. We'll talk more about this when I graph here in just a minute. But when you have 2 vertical asymptotes, it's okay to cross the horizontal asymptote, which is kind of strange looking. All right, let's go find that horizontal. So my degree of my top is 2. The degree of the bottom is also 2. Again, the biggest exponent on x, so these are equal. When they're equal, I'm going to do y equals my lead coefficient divided by my lead coefficient, so y equals 1. All right, for my x-intercepts, I'm going to take my top and set it equal to 0. I've already got those in factored form, so let's just use it the way that it is over there in factored form. So this one's going to be where x is equal to negative 1/3, so that'll be at negative 1/3, 0. And this one's going to be where x is equal to 5, so that will be at 5, 0. Okay, and then y-intercepts, I'm going to plug back into that original form because I know 3 times 0 squared is 0, minus 14 times 0 is 0, minus 5. So it's going to make everything with an x go away when I plug in 0. 8 times 0 is 0, minus 16. So that's going to give me negative 5 over negative 16, or 5/16. So 0 and 5/16, which is kind of a funny number, but that's okay. We're just going to graph it. Excuse me. Okay, so let's start with those vertical asymptotes at negative 4. X equals negative 4 right here. And at 4/3 over here. And then my horizontal asymptote at 1. So let's see here, let's put 1 right there on that line. So horizontal asymptote at y equals 1. So right there. Okay, then I've got x-intercepts at negative 1/3, 0 right there. And at 5, 0, so 1, 2, 3, 4, 5, 0 right here. And 0, 5/16 will be kind of right there. Okay, Okay, so this one's kind of funny looking. Again, over here I don't have any x-intercepts, so it's going to have to be up here above. So this piece of my graph is going to go right here. Again, we could plug in a number and find that, but it's going to have to be right there. Then again, when you have two vertical asymptotes, you can cross the horizontal asymptote. It's usually on this piece that's in between. Sometimes it's over here on the side, but usually it's right here. So again, I'm going to connect these 2 points going towards my asymptote, and notice it doesn't come back down because there's no more x-intercepts. So it's going to go up and cross that asymptote, and then also come down towards this asymptote. Okay, and then finally, I know this piece is down here because of my other x-intercept, so it's going to look a little bit of something like that. Okay, it's a really strange looking graph on that one. Okay, the last one we're going to work together is number 11. Number 11, I've got a of x this time. Alright, so again, my first step is to factor, so I'm going to factor that into x and 3 and 1, and I'm going to add 3 and subtract 1 to give me 2. And down here on the bottom, I've got a difference of 2 squares, so I'm going to square root and square root, and one gets a plus and one gets a minus. Oops, I said one gets a plus and one gets a minus, but they both got pluses. Let's try again. Minus, like that. Okay, so before I start to cancel things out, I'm going to go ahead and find my domain. And the reason for that is it's going to help me with my whole and my vertical asymptote. So I'm going to take my 2 pieces here and say that they cannot be equal to 0. So x cannot be equal to -1 and cannot be equal to 1. Okay, so if we're writing that in domain form, it's going to look like this. So we'll bump right up against those asymptotes at 1, but then not use them again. Okay, this time I do have a whole, and that's because a whole factor here will cancel out with a whole factor here. Excuse me. Okay, whichever factor canceled out, the domain that goes with that is what's going to give me the x part of my whole. Okay, so this domain was over here. This one right here is what's going to give me the x part of my whole. So my whole is going to be at an x value of 1. Now from here on out, everything else that I do, I'm going to use my reduced equation over here. Okay, so don't ever go back to the original. From here on out, we're going to use this reduced equation here. I'm going to circle it in green so we know to always go back to that one. Okay, so to find my y value, I'm going to take this x value and plug it in. So that's going to be 1 plus 3 over 1 plus 1, which gives me 4 over 2, which gives me 2. So I'm going to have a whole at 1, 2. All right, now my vertical asymptote is going to be what's left in my domain, so that's going to be at x equals -1. Okay, so I used part of it for the whole, I used part of it for the vertical asymptote. Okay, for my horizontal asymptote, the degree of the top is 1. The degree of the bottom is 1. They are equal. So I'm going to do lead coefficient over lead coefficient. So y equals 1 will be my horizontal asymptote. All right, for my x-intercept, I'm going to take the top and set it equal to 0. So that's going to be where x is equal to -3. So it's a point, -3, 0. And my y-intercept, I'm going to plug in 0 for x. So that's going to give me 3 over 1, which is 3. So also a point, 0, 3. All right, let's get all of this on here. I'm still going to start with my asymptotes. So I've got a vertical at -1 and a horizontal at +1. So let's start with those. So vertical and a horizontal. Okay, then a hole is going to look like just a little open circle at 1, 2. Looks just like this, and it's what we call jump discontinuity, because your graph's going to just jump right over it, not go through that point. And then I have a y-intercept at 0, 3, right here, and an x-intercept at -3, 0. So this one's kind of nice. It gives you enough points. So I'm going to go towards my asymptote, and on this one I'm going to go towards that hole, jump over it, and go out towards my asymptote, and then same thing on that side, just like that. Okay, so your assignment today is to finish numbers 1 through 18. We just did 4 of them for you. So try numbers 1 through 18, and we'll pick up with number 19 tomorrow. Have a great day.